Hey, good morning. Welcome to
FamilyMath119.
FamilyMath119. We're going to do another Fawn Nguyen problem today. Should be fun, right?
Yeah.
Okay, so earlier last week, I think it was Thursday, remember when we built those little snap cube models of almost cubes?
Yeah.
Yeah, so she tweeted a neat problem that one of her students had discovered, that if you take something like 2 times 3, which is
6.
6, you get something very close to the middle number squared. What's the middle of 2 and 3?
2.5.
2.5, 2.5. And do you happen to know what 2.5 squared is? Or do you know what 25 squared is?
25 squared is 125. Wait, no. 25 squared is 625.
625. So what do you think 2.5 squared is?
6.25.
6.25. And so one of her students noticed that this is always true. If you take consecutive integers,
Yeah.
their product is 0.25 less than the middle number squared. So that's pretty neat, right?
Yeah.
The only problem with talking about this for us is that you and I really haven't talked about decimals,
No,
right?
we
And so it brings an unnecessary confusion to it. So what we're going to talk about and see if you guys can find the rule for is numbers that differ by 2. Okay? So let's do a few. So let's do, where do you want to start at 1?
Okay.
1 times 3 is
That's 3.
3. Okay?
And then, so the middle number is 2, so 2 squared is 4.
2 squared is 4.
Well, now they differ by 1.
Okay. What's the next set of numbers?
2 and 4.
2 and 4.
Which is 8, and 3 squared is 9.
Okay.
Maybe
Okay, let your brother do the next one. Okay, what's the next one?
Is 3.
Let your brother do the next one.
so it's going to be 3 times 5, which is 15, and 4 squared is 16. Looks like these numbers are always one. It's 1 smaller than the middle number squared.
Yeah, it sure looks like it. So why don't we use our snap cubes to take a look at this? Can you show me? Can you build something with the snap cubes that represents 3 times 5? I think that'd be a good thing to do. Which color do you want to use?
Let's use orange.
Okay. Why don't you and your brother work together to build something that represents 3 times 5?
Well, you could do a 3 by 5 rectangle.
Okay.
2, 3, 4, 5, and 2, 3.
A little floppy.
That's okay. That's okay. And I'm going to build the 4 by 4 square, and mine will probably be even floppier. So what did we notice about 3 times 5 and 4 times 4?
Well, they're almost equal.
That's true. Can you be a little more precise?
Well, 4 times 4 is, it's 1 bigger than 3 times 5.
Looked like it was 1 bigger. Okay.
That's weird.
So here's my question, my challenge question to you guys. This is 3 times 5, 3 times 5, good. Don't touch it yet, let's just talk about it. But can you see, if these almost have the exact same, in fact there's only one different, can you see how you might very simply be able to turn this into almost this very easily without just...
Yeah. I have an idea.
Okay, what's your idea?
Oh.
Aha!
But then you have 1 square missing, so that's what we want.
Okay, so why don't you grab a different color cube, maybe a red one, or a white one, or no, actually a red one, so it'll show up, okay? See a red one?
Yeah.
These.
Okay. And put it in the hole. There you go. Look at that. How neat is that? So the other one, the consecutive numbers one, is the same idea, except each block you have to use halves. So that's fine. And now I just wanted to show you, kind of for fun, a little bit of the algebra behind why this is true.
Cool.
Okay. So we're going to have 3 numbers. Okay. Now you've seen this a little bit. You haven't a little bit. We have 3 numbers. Let's call it A, B, and A, C, and B right in the middle. So in this case, we did 3 times 5, and then 4 was right in the middle.
Yeah.
Okay. So what I'm going to do is I'm going to call the middle number something. What should I call it?
X.
x.
Yeah, x.
Okay. What was the number that was directly above it? If don't let your brother see
Let's
this.
call it y.
Well, it's related to x though. It's right above it. How is it related to x?
Well, well, you can call it x plus 1.
Very good. X plus 1.
And you can call this x minus 1.
X minus 1. Okay. So our equation said 3 times 5, which represents what times what here? You can go ahead.
X minus 1 times x plus 1.
X minus 1 times x plus 1.
Maybe this
Okay, and what should that equal according to or what should that nearly be equal to according to our?
Well, it should be exactly equal to x squared minus 1.
Okay, we found that this was x squared, and x squared was a little bit too big.
Yep,
And
then be minus 1.
So we have an algebra expression here that says x minus 1 times x plus 1.
Equals x squared minus 1.
So that's how we translate what we were studying here into a mathematical expression.
Well, if this is x minus 1, but then this is x squared minus 1.
That's true. Yeah, we will later on we'll learn how to multiply these out. But right now I'll just show you because we haven't studied algebra yet.
No.
Right? So we multiply it out just exactly like how we multiply numbers.
Yeah.
So we do an x times x, which gives us
It's 2x,
x times x,
x squared.
x squared. Then we do this x times this one
Then that's just x.
plus x. And I do this minus 1 times this x. What is minus 1 times x?
Well, it's minus 1. It's
Like if x was 4.
negative. It's gonna be negative x.
Negative x, very good. And then I have minus 1 times plus 1, which is
Well, it's gonna be minus 1.
minus 1. Then we add them all together. X squared plus nothing is x squared. Plus x minus x, or
It's
x minus x
0.
is 0. And
So
minus 1.
minus-
Look at that. So that's how we can go from our blocks up to our into our algebra, and then our algebra tells us that this is true. And this is a special thing, a special expression called the difference of squares, right?
I think
Right.
we've heard about that
Yeah. Where did we hear about that?
in one of our movies.
And we made a movie about difference of squares, right?
Yeah.
Where did we go to study difference of squares?
We made a little poem.
We made a poem. We went on the stairs to study a difference of squares, right?
Yeah.
That was fun. All right. Good job, guys. Good job.